right, let's get started. Good morning, everyone. It's a pleasure for me to introduce today Diego Tuccillo for the next episode in the SMAC, in the short seminar meetings for astrocomputing series. And following up on the previous talk that was on introduction to the numerical libraries, scientific libraries for Python by Jorge Andres. Now today we have Diego Tuccillo, who is a postdoc at the ISC, specialized in data mining and machine learning, giving us an introduction to the Pandas library for Python. As usual, please keep your microphones off and your cameras off. And there will be an opportunity for questions and comments at the very end. And if you wish to formulate a question, please use the chat to indicate so, or to write a question if you prefer us to ask it on your behalf. Diego, please take it away.
Okay, thank you, Carlos, for your introduction. And it's a pleasure for me to give you all 34 presents this little overview on the Pandas library for Python. So what is Panda? Panda is a powerful Python library, open source, that is widely used nowadays in the data science community. It works for manipulating and retrieving data from relational databases. And as all Python libraries is very well documented. So if you go in the page of Pandas, you can have a powerful, a very good documentation that can help you in using the Pandas. Now, because we are talking about relational databases, let's do just one step behind and remind you what is a database and what is a relational database. So in general, the database, we know what it is. It's just a set of related information. And because searching in a database, searching in a large set of related information is very much time consuming, it's not surprising that's one of the first applications of computers. It has been developing mechanism to retrieve information in databases. Historically, the first type of databases are the non-relational databases developed by IBM in the 60s. So in the case of not relational databases, the structure is in which the information is stored. The structure is the one of a tree. So in order to retrieve an information, you have to navigate through the tree and find the final information at the end of the tree. So it's not very different with respect to what you do in your own computer when you navigate through the folders. There are, of course, some variations of this concept, but this is in general a non-relational database. But about 10 years after, 10, 20 years after the starting of a non-relational databases, a new paradigm arose, the relational databases. The relational databases is the one we are used the more used. Now it's basically the way how databases are stored, are built. So in this case, the information is stored in form of tables, different tables, and with some redundant information. So in general, you have like different tables, and in order to understand that one row is referred to the same object of another table, you have these columns that identify the object, called the primary keys, and are the ones where you do the cross match with SQL and this. So in case of Pandas, we are talking about relational databases. Pandas was created in 2000, starting from 2008 from Wes McKinney, that also has written this book that I think it's a very good book. So it's my advice to, if you want to learn more about Pandas, to download it. Well, to buy it, not. But anyway, you can also download it in internet. And this guy was working with relational databases, and he found very many problems with standard tools. So he tried to develop an open source, a free tool in Python, in order to address all the problems that he found in other tools. So here I enumerated some of his own words. So he wanted something that was flexible in handling missing data, that had the same structure for handling both time series and data frames. Well, yes, relational databases. Also, he wanted to do something where it was easy to make arithmetic operations, but also statistics, plots. In fact, Python is written upon NumPy, that I think you have seen last week with well, a couple of weeks ago with Jorge, and on the top of matplotlib. So on the top of the libraries that Python use for managing arrays and for doing plots. So in this, I am using a Jupyter notebook, as you can see, and we are just going to see some of the applications of Panda, just to give you an overview on its on all the potentiality of this library. It's not at all a complete overview. Pandas, also because the data scientist community is very active in these years because of the rise of machine learning and in general of the big data. Every month, basically, there are a new development of Pandas, the development of new libraries developed on the top of Pandas, alternatives. So it's really a very dynamic world. For example, one of the reasons why it was created, Pandas, was also because it was very easy to manage big data. But nowadays, this is not anymore so true. So there are other libraries that are more suited for using the functionalities of Pandas on larger data sets. But anyway, it's still very good for databases, including many entries. So as usually, the first thing that you have to do is to import the libraries, of course. And it's because Pandas is written on the top of NumPy and matplotlib, it's better to import also these libraries when you import them. So in Pandas, there are mainly two types of structures. The first one are the data frames. The data frames are basically a table. We are going to see it. Okay, with some labels and the entries. And the second type of structure managed by Pandas are the series, the time series. So it's a one-dimensional array with a labeled one-dimensional array. And the same functionality, most of the functionality that you can apply to one, you can also apply to the other one. The main one, of course, are the data frames. So we are starting to this. Let's see, there are several ways how you can create a data frame. Let's see one of the simplest. In this case, as you can see, I created 3 arrays, NumPy arrays, A, B, and C. In this one here, we are just creating an array. Well, I can run it and cell, insert cell above, and so as you can see, in this case, A is just an array from 0 to 12, where I added 8. So now it's from 8 to 19. Then the B is an array of 12 random numbers. And the C is an array of 12 entries equally spaced between 18 and 25. Now, once you have the arrays, this is the way how you create a data frame. Very easy. You just give the name of each column, and you indicate which one of these column is which. So A is A, B is B. Not very, I didn't use a lot of fantasy here, but yeah. So, and this is the data frame that you can see, no? So you have the columns, the entries, and each one of these has an index. Now, there are several ways how you can explore a data frame. You can use the function head. Oops. Yeah. The function head that basically in this here between parentheses, you have just to indicate the number of not columns. Here there's an rows that you want to visualize. So here is 0, and you will see just the name of the columns. Here it's 4, and you can see the name of the first 4 rows. Of course, df is just a name that we have given to the data frame. It's not a convention, of course. So here, for example, I can call the same another data frame as Pepe. And in this case, if I call it Pepe, also every time that I use one of these functions that I will give, I will just have to indicate Pepe, the name of the data frame, and then the function. So in this case, the first 5 rows of here they go. The first 5 rows of the data frame Pepe. Okay, this is not the only way to explore the data. We can also try tail and shape. Let's see it together. Insert cell above. df punto tail, and for example this. So as you can see, in this case, as opposite of head, in this case you don't see the first 4 rows, but you see the last 4 rows. Another function is punto shape, and in this case, as you can see, you just see the shape of the data frame. So 3 columns, 12 rows. Other ways to explore the data frame is just giving df point columns, and it visualizes the name of the columns. The indexes, so in this case it says, you see, okay, it's from 0 to 12 with the step 1. So insert cell below. Let's remind how looked like. You see, this was the data frame. So it just says that these are the columns with the df columns, and these are the the index. Step 1, because you can also use another step and you can change it in order to make it in another way, like from with a step of 5, 0, 5, 10, and stuff like this. Or in case you are extracting a data frame, you will have just the sum of the index. And okay, but so this is enough for having an idea of the overall shape of the data frame. But this is not, of course, all that you can summarize with Pandas. You can, with the function describe, you can just have in one quick vision all the main statistics of the columns. So you write df point describe, and you will see the mean, the standard deviation, the minimal variable, the 25% percentile, the max, the minimum of each one of the columns. With Pandas, it's also easy to, okay, here it's in general is easy to manipulate the data frame, but here was not the point. I just, in this case, I generated another array with duplication. Before, you remember, it was from 8 to 19 as here, and here I created some duplicated values. So there are 3 entries of 3. This is because with Pandas you can easily have visualize the frequencies of each values. So here with this function df, you specificate which columns, and and you say count how many times each entry enters. And as you can see, you will have these. Okay, this is confusing because it's noisy. Let's do that. Okay. So as you can see, it says in the column A, we have the number 3 times, the number 15, 1, the number 14, 1. So with this simple command, you can have a view on how many times, the frequency of each value. You can have this works not only for numerical values, but it's very flexible, and it works also for string types values. So in this case, I manipulated again the array A, and as you can see, I entered here from 1, 2, 3, 4. Pepe 6 times, no? In the string Pepe 6 times. So in this case, using the same function as before, value kinds, it keeps working, even if it is now a mixed array. It's not anymore a pure numerical array. And it says us that Pepe, the name Pepe, is enumerated 6 times, and 17 one time, etc., etc. Now, as I told you before, Pandas is written upon also matplotlib, not only NumPy. So we can also have access to many of the functionalities of matplotlib, and we can have also a quick visual summary. We can summarize the data frame visually with the histograms in an easy way. So in this case, we are saying that we want the histogram of the column B in bins of 5. So as you can see, in one command, we can just explore how it looks like the distribution of the values in this for this column. Now, something that I was thinking about now, and I wanted to point out, one of the main functionalities of Pandas, one of the most useful, okay, is that you can combine. We will see it through this tutorial, that we can combine different functionalities with just adding the functionality with a point. So if I just write dfb, it will visualize me the column B. Now, if I add a point east, it will give me an histogram. So, but he already knows that the histogram is about the column B. Now, so you can combine very different, and also there are different ways how you can visualize. You can do the same thing. It's not very strict, so you can also use different notations. You can indicate, for example, one column in this way, or you can write df point, the name of the column. So it's flexible. Exercise the histogram of C, it's not very needed. You can also visualize not histogram, but box plots. You have access to many types of different plots. So in this case, we are visualizing a box plot of the column B. You can see the median, the interquartile values, and here there is an outlier. And here I just wanted to point out how box plots are useful to find outliers. This is not really for you, that you are astronomers, you know what is an outlier and all. So because you can also make groups of the data frame. So divide the data frame in subgroups. So let's see what I mean. In this case, I changed the column A in chicos y chicas, so girls and boys. Now the data frames looks like this. Like all the values B, C, and D are referred to chicos, to boys, and all these other values are referred to girls. Now, Pandas is very useful to subdivide the data frame respect to a column, to a given future. So in this case, we say this box plot, so the same functionalities of before, but column of the column D, so divide, let me see these values. I don't know what could be, I don't know how many euros has in the wallet each one of these persons, and by A. So subdivide the data frames in these two types, girls and boys. And as you can see, you will have, with just one command, these nice box plots that can give you a quick overview on how the things are going. So we can see, if we say that the column D was the euros in the wallet of the guys, that's in general the girls are more rich than the guys. I don't know if it's true, but in this case. Now, also, yeah, these are just some of the plots that you can do. In general, many of the functionalities that you have in matplotlib, so you can also do it quickly in Pandas. So in this case, for example, where the histogram doesn't look very nice in this representation with this scale, you can change the scale of the logarithm, the scale in, okay, here you can do it directly in the histogram. Here I just changed, I see the values of the columns instead of doing this in the histogram. Okay, so one of the reasons why Pandas was created, as I told you before, is it clear everything up until now? No, here the questions are all at the end, no? Okay. So, as I told you before, one of the reasons why Pandas was created was to handle missing values. Everyone that has worked as a data scientist or in general have deal with the large databases knows that the missing values are very huge problems and in general a pain in the neck, let's say that. So Pandas can handle this again in just one line or few lines. In this case, we, as you see, I included one non a number, no, some missing values here in the column B. Now, with Pandas, you have many routines to deal with outliers. You can just count the outliers with the function. This one, df apply lambda. Lambda function, we will see it later. The lambda function is basically you can apply, you can do it. It's a way to define your own function and reiterate it in different columns of your data frames. Let's say that in general, the way to find missing values is this. This is the command. But because with Pandas we can do combinations of different routines. Here I used just the lambda function to apply this function to all the columns, and so it says us that the column A, it doesn't have any missing values. The B has one, we know it, we created it just for the purpose of this exercise, and the C and D has 0 missing values. Once you find that you have a missing values, you can easily fill, you can eliminate, you can drop this line, and we will see it later. You can drop this row, or you can fill these values with another value. In this case, I specified that in the column B, fill the not a number, the missing values, with the mean of the other values. So basically, it takes the column, calculates the mean, and it replaces the missing values. I think it was the 8, I don't remember. No, the 5, the 5th. Okay, replace this not a number, these missing values, with the mean of the whole column. Here in general are the general functions to deal with missing values. You can so you can, for example, fill it cell, insert cell below. Well, okay, I should also specify the column. Okay, you can also, for example, fill it with a number. Here I say 0, but it could be 5 or what else. And with the function drop, you can drop the whole. Well, I'm not going to do it because I want to use the same data frame for the other examples. But let's say that with this function, you can eliminate one row or an entire column, and it changes just depending on. You can change it just changing the values of the axis. If the axis is 0, you eliminate a row. If the axis is 1, you eliminate a column. What else? As I told you before, Pandas is also useful for manipulating the data sets. So let's see what we mean. Here we have defined our data frame. We can easily apply some of the same functions that you already have seen with the NumPy. So you can calculate the transpose of the data frame. But you can also apply some of the functions that are most commonly used in SQL. For example, you can sort the data frame respect to a column. Here, this was the column. Yeah, these are the columns. So here it's sorted. I don't understand why it has these values. Let's see. Run. Okay. Sort by D. Okay. So as you can see now, it's sorted by D. And from the 20, so from the minimum values to the maximum values. You can also change the criteria of the sorting just with this. You can do ascending through. Yeah. And it will go as it goes by default from the minimum to the maximum. But if you do false, it will do the opposite, from the maximum to the minimum. I don't know if you are liking Pandas so far, but I find very incredible that you can do a lot of stuff with just one line. You can select, and you can select, as I told you, one column in particular. In this way, run, and it will visualize all the columns of one. Okay, all the values of one column, the column A. You can slice, so you can look at just, for example, from the index 0 to the index 2. We can also take it in the middle. You can end with the function lock. You can be more specific. So you can say which index do you want to visualize and about which column. Okay, and you can also, in this case, you look at the third row, no? In this case, index from 1 to 3. So you have, well, my point here is just that you can specify the columns in two ways: giving the names of the columns, or giving the number of the column. This is so for from the first to the third column. Again, okay, here we can add, we can also easily add other values, other columns to the data frame. So this is how it looks like our data frame right now. I can, for example, create, for the sake of an example, create another array of zeros. So cell below. This is an array of 0, and if I want to add this array to our data frame, so here I can just very easily say df, the name of our data frame, the name that we want to give to this new column, and the array, the values of this column. So as you can see here, with one column, with one command, I have a new column added here. Of course, I can also, if I use this functionality, it will be added at the end of the columns as the last column. But I can also use another functionality that's here. I didn't mention, I guess. No, I didn't mention it. It's the df point insert, and you can specify in which place, if, for example, you want to insert the null column among two different columns. There are thousands of functionalities in Pandas. Basically, you can do everything, and with the data frame. So and you can easily rename the column. So here we df.rename, and you can change the name from null column to zeros. Rename, run, okay, and that's it. We renamed it. This is the function drop that I was talking about. Was I talking before? So in this case, I told that I want to drop this column among the axis 1, that is the vertical line. So I do this function, and as you can see, it goes from zeros to here. So it eliminated the last column, the null column. What else? Because we have said that Panda is very it was used it was created by someone that was dealing every day with databases. We know that one of the main functionalities of databases are the queries, no, the SQL queries, and you can do it also with Pandas. So you can do it with Pandas in this way. This is, for example, what we are doing here. We are specifying that in the data frame, in this data frame, we want to visualize this data frame when the column D is bigger than 200. So, okay. This is. Now, if I want to see respect to the column C bigger than 200, it will give nothing, because as we can see here, no values are bigger than 200. And you can also combine different queries, no, different specifications in this compact notation. So you can specify that you want to visualize all the values where the column D is bigger than 70 and the column C is bigger than 23. Or I can do the opposite and say smaller than 23. And that's it. We have C smaller than 23, as you can see here, and D bigger than 70. You can also apply statistics and to some, in general, to the whole data frame. Here, for example, I'm just using this. The mean of the whole data frame. So, or you can also specify insert cell below. You can also specify one specific column. For example, the column C. We want to know the standard deviation, for example. Okay, we do run, and that's it. We know the standard deviation of the column the column C. And you have access to many different functionalities, minimal, count, also the cumulative count. So yeah, nice. You can subgroup because, as I told you before, we can combine the different functionalities of Pandas. In this case, we combined the functionalities of grouping, of doing subdividing the data frame in groups with the mean. So in this case, what we have done? We have taken the data frame, we divided this is where is the data frame? Well, okay, I can visualize it here. Just insert cell below, df, run. Okay. Okay, in this case, I don't have any more chicos because I didn't run all the cells. So we will just use what is written here. Here, as before, the data frame was divided in some entries that were chicos, boys, and some of chicas. So with these functionalities, we divided the data frame respect to the column A in chicos and chicas, and then we calculated the mean of all the columns respect to these two different categories, no? The mean of B, C, etc., etc. Before, I don't know if I think I'm going well, no, with the time, yes. So, other functionalities, as I told you before, there is this, the Lambda function. With the Lambda function, if there are some functionalities that are not implemented in like the mean, the standard deviation, some functionality that you want to implement and create, this is the way to do it with the Lambda function. In this case, you are saying that you want to apply to the data frame the Lambda function that is x equal x for multiplied for 2. So what is doing this? It's taking all the values of the data frame and it is multiplicating the values for 2. You can do it, of course, as I told you, just adding another point. You can specify to which column you want to apply the Lambda function, as similar as you do with mean, standard deviation, and all these. And okay, and you can combine Lambda with other functionalities, for example, filter, then also map, reduce. With filter, you are filtering the values of C so it's similar to a query in this case, the queries that you have seen before, but in this case you can define a function lambda, so it can be more general and it can be combined with other functionalities. The other structure of the other kind of structure that Pandas deals are the series. This is a series, so it's just values, labeled values. Okay, this is a one-dimensional structure. Now, the reason why Pandas it's widely used in the data science community is because it deals with a large, with many different types of data. So up until now, we had just created the data frame, and we have seen some examples some examples we have done with that data frame. But we can, of course, import a table. So, and we can import a classical comma-separated value. We can write, once we have manipulated it, we can write the CSV file out as an output, but we can also read Excel files, we can read SQL queries, And it's not all. It's not a complete list. We can also import JSON files. Basically, most. I would say all, but I want to be so. All the main types of extensions for a table. We can also reshape the data frame. So in this case, let's see, cell, insert cell below. Our data frame was this, okay. With melt, let's see what we do. Okay, df, print. Okay, well, melt should, didn't work. Yes, of course. Okay. So melt basically takes all the columns and it reduced the two-dimensional data frame in one-dimensional array. And you can have access to other functionalities that are typical of SQL. You can concatenate the data frame. Here, in this case, I concatenated the data frame with itself. So let's see. In this case, vertically. So here we have, it was 12 entries. So 12 entries, and then it is concatenated again to the same data frame. But you can concatenate, of course, with other data frames. And you can do the concatenations also horizontally, just again specifying the axis. And that's basically all I was going to talk about Pandas today. But as I told you, this is just an overview of the many functionalities of Pandas. With Pandas, you can do much more things. You can even do web scraping. That for the ones that are not familiar with the word, is basically you can search a website with Pandas and search for the values, do statistics, import explore the website, and yeah. Now, for you, because I know this is a lot of information, I created this because it is a cheat sheet that I'm going to give you in the yeah. You can download it using this. So here it's just a cheat sheet for starting to use Pandas, and are most of the things that we have seen. Well, the things that we have seen today is how to load, export the dataset, as how to examine the dataset with the Pandas, selecting and filtering, the statistical operations, the data cleaning and modification that we have seen, grouping and aggregation, and how to merge the data frames. This, well, also the concatenation, the stuff like this. This is just for starting, of course. Then once you will move your first steps in Pandas, I'm sure that if you used to deal with large databases, you will see the appeal of Pandas, and you will become addicted and find in internet that all the main functionalities of this. Okay, that's all. Let me see here chat. I can share with you this is the link. You can download the cheat sheet here. Right. Okay, that's all. Thank you to everyone. If you're still not sleeping.
Thank you, Diego. Well, let me first try to unmute people. Actually, yeah, it's time for questions. So Let me see if so. I suggest people write the questions in the chat. So actually, Diego, you can go. So there is one question by Carlos Westendorf saying, "Is it fast with large data frames, or do you ever have to switch into NumPy arrays, vectorized, because of this?"
Excuse me, can you repeat it?
Sure. Yeah. So Carlos Westendorf is asking you whether it is fast with large data frames, or if you ever had to switch into NumPy arrays to convert your data into NumPy arrays because of this.
Okay, so one of the main reasons Pandas was created, it's because it's fast. So, and it doesn't really, I don't find many difference between a NumPy data frame or a mixed data frame. This is one of the main functionalities in general of Python, that Pythons can deal both with numbers and mixed types of data. No? Now, of course, everything depends on what you mean for large. So large data frames in general, Pandas works well with large data frames. Now, because large, the definition of large is getting bigger and bigger, there are now, as I told at the beginning, there are now rising other libraries that are more suited for extremely large databases. And if you want, you can just write me an email and I can give you I can tell you which are these libraries and the reference to these other libraries. But I would say that in general, Pandas is very well suited and it's fast for dealing with large databases.
Okay. Thank you, Diego. So, yeah, any more questions? Yeah, another question by Carlos Allende. He's asking whether does it come with the functionality to read fixed tables or HDF5 data frames?
Yes, of course. Thanks, Carlos, for this question, because I forgot about fixed data, and I know that is for astronomers is are very important. So yes, there are functionalities to import fixed tables and also to write in fits as output. So and also HDF5 data frames. Yes. Both.
Great. All right. Yeah. So he thanks you. Thanks for the talk. How do Pandas works with make data?
What?
I don't know if you can read the chat. It's thanks for the talk. It's mass data. Understand the word with max data.
Masked data.
Yes.
Masked data. You mean when you have to discorporate the? Yeah. Okay. It's tricky, but you can do it. Sometimes it's tricky, but you can do it. Yeah. It's not straightforward, I would say.
Okay. Any more questions? I think we're doing great today. It's like 6 minutes before